How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to be taking a look at BGP and route maps. Now, this is something that we're going to be diving into quite a bit with in the future when we get into the best path selection algorithm. And honestly, anytime we do any redistribution of anything from, OSPF to any routing protocol to another routing protocol, and we need to control routes and things like that. So you're going to see route maps a lot throughout the series. Sometimes you're going to know what they are, as I'll go through the explanation. Sometimes you won't. So what we're going to be going through and doing here is kind of giving you guys a high-level overview of what the route map's job is to do. So there's a lot of things that come into play with it, and we are going to use it to make sure that everything is working the way we expect it to. So before I get into, I'm going to walk you through what it does, and then once we understand what it does, then we'll be able to go through and talk a little bit more in detail of when you use it, so on and so forth. So without any further ado, a route map is a filtering mechanism in Cisco IOS that allows the routing process to call various features when making a routing decision. So it is a if-then-else filter, like object-oriented programming, like Visual Basics. So the if is the match clause, then is the set clause, and else if is if nothing else is matched or set, move to the next forwarding engine. There's a couple of things that you can do with the route map. One of those is without the continue option. So after the match occurs, the route map stops evaluating match clauses and starts executing set clauses. And this is important. So most of the scenarios we're going to walk through are going to be route map based without the continue option. However, you can go and create route maps with the continue option. The route map with continue will continue to evaluate and execute match clauses in the specified route map entry after a successful match occurs. The continue clause can be configured to go to, basically it's a jump to a specific route map entry by specifying the sequence number. If a sequence number is not specified, the continue clause will go to the next sequence number that's been defined. This behavior is called an implied continue. If a match clause exists, the continue clause is executed only if a match occurs. If no successful matches occur, the continue clause is ignored. So if you have match operations with continue clauses, if a match clause does not exist in the route map entry but a continue clause does, the continue clause will automatically be executed and go to the specified route map entry. Set operations with continue clauses. Set clauses are saved during the match clause evaluation process and are executed after the route map evaluation is completed. So that's going to give you the specifics, right? So what are we going to use a route map to do? A route map is going to be used to match on different variables, capabilities, things like that, whether that's a prefix list, whether that's an AS path list, whether that's a community value, things like that. And the set command is going to be used to, once a match occurs, what do you do with that? Do you set the local preference? Do you remove the community value? Do you prepend an AS path? Do you drop the traffic? Well, what do you do with that particular capability? And when you start digging into the weeds of how this works, it's not super complicated. I'll be honest with you, it's really not. What it is, however, it needs to be thought out. And I'll give you a great example of why it needs to be thought out. When you create a route map entry, and I'm actually going to pull up iOS for this so you guys can see what I'm talking about. Go ahead and log in. Pull up the CLI here. If I was to log into, say, router 26, and if I was to go and create a entry, I'm going to create a route map, and then you give it a name. If you give it a name of test, hit the question mark, you can give it a sequence number of 0 through 65535, so it is a 16-bit value. And let's say we give it a route map entry of 10. If you say 10 without giving a permit or deny, it's automatically going to take it as a permit statement. So it's going to be route map test permit 10. So we sequence 10. Once I'm underneath here, you're going to have a couple of different options. Here you have the continue, and you can specify the sequence number you want to continue to. You also have the match option. Match is going to match on additional paths, AS path, external extended community, a community, interface, IP, IPv6 length, local preference. You see all the different capabilities that you can match on. So it gives you a lot of flexibility. The set command is going to give you even a little bit more. What do you want to set when you do this? These are options as well for you to manipulate if you would like to do so. Now, the reason why this is important is because when we go through and configure it, if we configure it, let's say we configure correctly, but incorrectly at the same time. Most of the time, what's going to end up happening is if we do show run pipe section route map, here we only have one route map. There's no match. There's no match. There's no set. If I have this route map configured and then I apply it somewhere, it's an implicit permit. It's going to happen by default. So let me talk a little bit about how this is going to work with things like prefix lists and stuff like that. So what you want to do, and this is going to be kind of a weird behavior, so just follow my line of thought. If I am going to be using something outside of the route map to do to be the match statement filter, access list, prefix list, community list, AS path list, anything like that. Those entries, whatever they are, access list, IP prefix list, and so on and so forth, those need to be configured as a permit. They need to allow that traffic to hit. So it's going to hit the filter, and it's going to be allowed to pass through. That's what it's going to do. Now, what will end up happening is, let's say you want to deny that traffic. Okay, no problem. If you want to deny that traffic, then what you're going to do is, after you've created a permit entry in the prefix list, access list, community list, AS path list, etc., what you're going to go do is you're going to, if you wanted to drop the traffic, you're going to map that particular prefix list to a deny entry in a route map. So you want the traffic to get to the route map in order to get dropped. It's kind of a weird conundrum, but that is essentially what it is that you want to do if you're going to be doing any type of deny entries. What you don't want to do is you don't want to deny in a prefix list and then deny in a route map, because a deny in a prefix list and a deny in a route map will actually permit the traffic. Kind of a weird, it just doesn't make sense, right? You think that's a double deny, right? I don't want to do that. Well, it has the opposite effect. Two negatives do equal a positive here. So whatever you do, don't do that. So you want to match in the prefix list, match in the access list. Those are the two that you could actually specify permit or deny. Community lists and things like that, if you were to exit out and do a community list, IP community list. This is just going to match on let's say an expanded community list entry. We'll give it a name, test, and then we can specify, well, actually it's permit, and then whatever regular expression you want to do. The AS path list is the one that you don't care about. There is no such thing as a permit or deny AS path. It's simply there to match on, and then you can deny in a route map. So that's essentially what that would look like. So if, for example, let's take a hypothetical. Let's say you have a certain set of subnets that you want to affect by a route map entry. So you're going to create a prefix list that's going to match on those subnets. You're going to call that prefix list through the route map. The route map is then with the match statement. Then you want to set the AS path prepend to, say, add 3 AS hops to the existing AS path list. Simple enough. So you go and you type in AS path prepend and you type in, 10, 10, 10. Right? So it's going to add 3 additional AS path hops to your AS path list. Now what's going to end up happening is if I just let that sit by itself, I'm only going to allow those subnets to pass through. Now I might have a whole bunch of other subnets sitting behind there that I need to allow to come down to wherever I'm going. But if I only have a prefix list that matches on those specific subnets and I don't allow anything else, I'm going to be blocking a lot of traffic. So that is why oftentimes you're going to see route maps with multiple entries in them, where you're going to have a route map entry, say, 10, that will match on specific traffic, right? That prefix list that matches on that handful of /24s, and then sets the AS path prepend to be 3 additional AS path hops, no problem. Then you're going to create another route map entry, and that route map entry is going to have nothing in it except for the implicit permit, meaning it's just going to be, sequence 20 permit, or well, whatever the syntax, permit 20. So it'll be route map test permit 10, and then match IP address prefix list X, set AS path prepend 10, 10, 10. And then you would have another line in there of route map test permit 20 with nothing in it at all except for just that entry. And what that would allow you to do is set the match on the prefixes that you want to match on, and then set the AS path prepend to those specific subnets. Once those are matched, then you're going to move on to the next entry in the prefix in the route map, and then when you do that, the next step will be to match on permit 20, which is going to match on everything else. Everything else will be allowed to flow through, and that's something you're going to want to keep in the back of your mind. I've made the mistake several times of like, oh crap, I forgot to allow that. So you go in there, you create a route map entry real quick, and then you just confirm that the routes are then propagated where you need them to be. So these are some things that you're going to want to pay attention to when you're doing stuff. So one thing I've always cautioned you on, especially if you're working in a production environment, is take a couple of extra minutes to review your configuration. If you can, peer review. Hey, this is what I've got configured. Does this look right to you? Yes, no, maybe so. And then, then you can, double check it. Don't ever be like in a hurry to get something done. So I'm talking from first-hand personal experience here. So that is what a route map's job is to do. You're going to see it a lot throughout BGP. Now, it also is heavily usable in redistribution. So we're going to see a lot of redistribution from an IGP into BGP because of the fact that we're doing MPLS VPNs. So I'm going to go ahead and show you what I mean by that. So MPLS VPN is down here. It's operational. It's working the way we expect it to. What we'll end up doing is on router, well, it's technically already been configured and done. So just be aware of that. So what we're going to do is we're going to redistribute between BGP and OSPF and OSPF and BGP. And there will be scenarios where we will have to control traffic. So if I need to be cautious about my redistribution, the way that I would do that is like this. Let's go ahead and pull up router 58, and I'll give you an example. So I'm actually recording this video after the fact, and it wasn't until I went through my notes I was like, oh yeah, I have to talk about route maps. So I'm going to do a show run section OSPF and route map. And actually, let me do this. And prefix list. So one of the things that I had to do when I was doing my redistribution of BGP into OSPF is the lab that I've got built here I'm doing a lot of, I've got it built in such a way that things that you would normally allow out to the internet are being allowed out until we fix that. We went through, the video's already been recorded. I'm just going back to make sure that I'm being thorough in my explanations and things like that so you understand what it means. What you end up having to do, just so you understand the configuration piece to this, is this. I have this prefix list right here called RFC 1918. And what it's doing is it is matching on anything RFC 1918 address space. 10/8, so 172.16/12, and 192.168/16. And I'm matching on anything from /8 all the way up to /32. That's what that means. Now, what I'm also doing is I've also got this prefix list being matched in a prefix list, in a route map right here, permit 10. This is match IP address prefix list RFC 1918. And by doing that, I'm saying I want to match on these 3 prefixes, but on anything else I want to deny. Now, normally speaking, like I just mentioned a minute ago, normally you don't want to have your deny entries in your prefix lists. But in this case here, it's okay, because I'm trying to be as wide as I possibly can, but still also be able to deny traffic if I need to. Normally speaking, I would have another entry in my route map of deny 20, and I'd be matching on this sequence, this particular route map entry, and I'd be doing that. That would also be applicable here, but for the sake of argument, I didn't do that because I decided to go with the deny entry here because the idea was that anything outside of that range, I didn't want to have to worry about the prefix list getting messed around with or having another prefix list that blocks the traffic. So I could have been more specific and said permit RFC 1918 and have permit statements, and have another prefix list that says deny RFC 1918 or deny public address space, or whatever the case might be. You can get very, very granular if you'd like to with your naming conventions and things like that to put logic into your configuration. All of that is completely up to you. But to get things done, and this did work at the time, and it's actually still working right now, that's why I have it still in play. That is why I have what I've got going on here. So what I end up doing is I take this guy right here, and I match it in the route map here. And then what I do is when I do the redistribution of BGP into OSPF, I set the metric to 20, so I give it a cost of 20, and I say I want to match on all of the, I want to do variably length subnet masks, so subnets, instead of matching on just the classful range. And then I map route map BGP to OSPF to it. So calling this route map references this route map, which references this prefix list, which references these permit statements and this deny entry. So that gives me flexibility. Now, as soon as I did that, and I was checking elsewhere in the network, all of a sudden, all of the public address space that I'm demoing here in my lab, that was internally in my IGP, went away. And that's one of the things that you'll have to learn how to do. We'll take a look at this more in detail once we get into the specifics, but this is essentially what we ended up having to do. This video that I'm recording here will actually come before some of the other videos, so that it'll make more sense. But this is essentially what we'll end up having to do. You'll see it beforehand of what we're going to implement. But this is one of those things where you have to understand how a route map can be used. This is just one variation of it. There's other ways to use route maps. We really haven't talked about redistribution a whole lot yet in this series. And so I'm going to definitely have to focus on that for a little while so that you guys can understand how the capability will come into play. Because redistribution, and you've seen it a few times up to this point, basic redistribution, right? How a router does picks up redistribution, how it determines what can be redistributed and all that type of stuff. We haven't really gotten into that yet. And only because of the fact that I'm digging into more advanced topics, I will be coming to that later on. It's just one of those things where I have to go through and talk about it at some point. I just don't know exactly where I'm going to fit it in. It might be I might do it multiple times. I don't know yet. We'll figure that out. But I wanted to go over just a basic route map overview of how this stuff is going to come into play. And if I look at router 62, I've got actually quite a few route maps here. Show run pipe section route dash map. There's a few different route maps here that we're going to walk through and how they're going to be used to prevent traffic from going where we want it to and things like that. The basic explanation here that I want you guys to understand is, at the end of the day, we are going to use the route map in multiple ways to control how traffic is going to forward where we either do or don't want it to go. That's the bottom line. So I will tell you that route map creation and how it's sequenced and how the logic is built isn't terribly difficult to understand. It just takes time to understand where to apply it. What do you configure? Where do you apply it? Things like that. And it's going to be one of those things like, for a video, the way I equate it is like playing a video game, or, I'm a big fan of first-person shooters, and I've got a couple on my computer that I'm recording on, and I'll spend maybe half hour to an hour every week or so. I'll jump into the game and I'll go bang bang shoot 'em up. But the longer you play the video game, the more acquainted you get with how it operates and how it works. So the same thing goes together with configuration, or sorry, I'm also a big fan of Texas barbecue. All right, so I will go buy a brisket from the store. I will go watch videos on YouTube on how to trim it, how to season it, how to cook it, how to serve it, all that type of stuff. And so the more briskets you do, which brisket is not an easy thing to cook by any stretch of the imagination, but you take that same consideration into play, you're going to have to spend some time with route maps, playing around with them, what's going to work, what's not going to work, and see exactly how that's going to come into play. So overall, it's not a very difficult decision to understand. It's just one of those things where you just have to go through the process of understanding what its job is to do. Basically is what it boils down to. So if you guys have any questions, comments, concerns, feedback on that type of stuff, feel free to drop a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you folks in the next video.